Hello, in this video we're going to see data visualization using Matplotlib library in Python. Firstly, we need to install Matplotlib library by using this command. I'm not installing it because I already have it. Then I import the libraries and modules. Matplotlib.pyplot, I'm calling it PLT, and NumPy, I'm calling it as NP. Now I'm creating the data. I'm using np.linspace to create an array of evenly spaced numbers between 0 and 20. Next, I'm plotting the data. plt.plot. Plot is the method to plot it. And the first parameter is the x-axis. Next parameter is the y-axis. And label is linear, which will be reflected in the legend of the plot. plt.legend adds legend to the plot. plt.show displays the plot. So this is the plot, x-axis and y-axis. For every x, the y is x plus 0.5. Next, we'll look at line graph of two series. First, I'm importing the library. I create a series 1 data. X is this and y is this. I'm plotting the series 1 data by using plt.plot method. X, y, and label is series 1. The color of the plot is blue. Next, I'm creating a series 2 data and plotting it again on the same plot, but this time the color is red. I'm adding the x label on x-axis, which is nothing but the name of the axis. I'm adding the y label on y-axis. I'm adding the title to the graph. I'm adding legend to the graph. And finally displaying the graph. So this data from series 1 and series 2 is displayed as two line graphs on this plot. Next, we'll look at a pie plot. The pie charts or pie plots are useful to show the proportional distribution of data, or in simple words, percentage of the data. If a group of items constitute 100%, then each part can be represented as a part of the pie chart. First, I import the libraries and creating a data here. It's the sales of 4 regions: USA, India, UK, and Japan. The sales is 25%, 40%, 15%, and 20%. I'm defining the plot here. plt.py creates a pie plot. And within parentheses, I'm giving the first input as the sales, the numerical value or percentages. The next input is labels, which is nothing but the regions here. Colors, I can give whatever colors I want. I'm giving red, green. This colors parameter accepts hex codes. We can give whatever color we want based on the hex code. Next is the start angle, is the angle at which the pie chart starts. It's at 90 degrees. I'll talk about these things after we look at the plot. Let's add title. And finally, let's look at the graph. So this is the pie chart which we have created. We could experiment with this by making it 45, then the angle changes. So that is what is called start angle. Shadow is the gray color which you could see here behind the pie chart. That is a shadow. We could make it false. Now there is no shadow. Explode is the pie India is separated from the pie chart. That is what is called explode. That's why I defined a list of values, and the second value is given as 0.1, which is nothing but the value of India. We could make it 0.5, which creates more gap in between. So let's keep it 0.1. And auto percentage is the value of the percentage here. If you make it 0, then you'll see only 25% here. So I wanted one decimal place after the decimal. That's why I've given it zero point 0.1, and double percentage here gives the value in percentage. Next is the label distance. So labels are USA, Japan, India, and UK. You could keep these labels outside of the pie or inside of the pie. Let's keep the label distance as 1.5. See, the labels have moved outside. Then you could get inside the pie. So that's why I'm keeping it 0.6. Next is the percentage distance. The percentage values here, these are outside of the pie chart. If you keep this value less than 1, then the percentages will be inside of the pie chart. If you keep the values more than 1, then the values will be moved outside of the pie chart. We display a pie chart using Matplotlib. Next, let's look at bar plot. Bar plot or bar charts are used to compare different groups or different categories of data. First, we import the library and then create data. There are 5 products: product A, B, C, D, and E. And units sold is the number of units of each product which is sold. Product A is 120, product B is 200, and so on. So to plot a bar chart, we use plt.bar products. The second value is the unit sold, and color I'm giving as green. You could give any color. You can give a hex code here. I'm adding a grid to the plot, which is the background grid. I'll tell you what that means once we see the plot. Then we add the title to the graph, product sales distribution, and display the plot. So this is how the bar chart is displayed for this data. So the grid line is this thin line which is in the background. I'm defining it as axis is Y. Line style is double hyphen. Alpha is the transparency of this grid line. It is between 0 and 1. If we give alpha is 1, then it will be very dark. If we give alpha as 0.5, it will be lighter. If I want the value of this inside of each bar, then we could use a for loop here. Let's say I, comma value in enumerate units sold. So enumerate units sold creates an index for each unit sold. plt.text is, it displays as text inside the plot. I, comma value plus 3. I is the first index. Value plus 3 is 3 steps points above that bar. HA center centers the text horizontally. Now if we display it, you could see the value of each bar displayed on top of it. Display the same bar chart with horizontal bars. To display the horizontal bars, you just need to change this bar h and change the x and y labels. Previously, the x label is products, y label is number of units sold. Now the x label is number of units sold and y label is products. We also changed the for loop a little bit to place the text horizontally beside the bar. So this is how the same data is represented on horizontal bars with the values on the side of each bar. Let's look at a histogram plot. Histograms are used for showing distribution of a continuous variable. So one important thing is this looks like a bar chart, but it's not a bar chart. It works only on single variable, whereas bar chart works on 2 variables. That's a major difference. So to plot it, first I'm creating the data. And I'm creating a bin here. The method is plt.hist. The first parameter is the data. Second parameter is the number of bins we want. We can create any number of bins here. Width is the width of each bar, and color is the color, whatever I want. Next, I'm adding the labels. I'm adding the title, and finally displaying the graph. So this is a histogram of employee age using Matplotlib. To create a scatter plot, A scatter plot has points that show the relationship between two sets of data. For example, here you could see height and weight, and each dot shows one person's weight versus height. For example, at this height, what is his weight? At this height, what is his weight? So a scatter plot has two variables, x and y. First, I'm creating the x and y data. I'm using a list comprehension here. X for x in range 1 to 13 if x reminder 2 is not equal to 0, which creates a list of odd numbers. Y is this data. I'm drawing the scatter plot by using plt.scatter. X comma y is the x and y variables. Color is blue. Marker is O. You could give it alpha is again for transparency. I'm adding the x and y labels. I'm adding the title, and I'm displaying the chart. So this is the scatter plot for x and y. You could change the alpha to 0.8, which makes the marker darker. If you reduce it to 0.5, the marker will become lighter. Let's look at a bubble chart. Bubble chart is a type of scatter plot, and the size of the bubbles can be mapped to a data point. So the size of the bubble also conveys some information. So bubble chart displays three numerical values, one on x-axis, one on y-axis, and the other as the size of the bubble. Let's see how we could plot this. First, I am setting the figure layout, which is the size of the plot. Next, I'm creating the data. So these are the population and GDP data of countries: Qatar, Luxembourg, Singapore, Brunei, Ireland, Norway, UAE, and Kuwait. Now I'm scaling the GDP data to show the bubbles in the graph. I'm dividing all the GDP data by 100 so that the bubbles can be seen on the plot. Next, I'm drawing the bubble chart by using the same method as scatter. So plt.scatter. The first data is the country's data or categorical data. The next data is population of each. S is the size of the bubble, which is mapped to scale GDP per capita. C is the color of the bubble. I'm again mapping this to GDP per capita. So the bubble color, if it is darker, that means more GDP. If the bubble color is lighter, that means less GDP. C map is the type of color which I'm using for this. I'm using reds. I can use blues or greens or anything. The edge color of each bubble is black. Alpha again is the transparency of each bubble. Next, I'm adding the X and Y labels. X label is countries, Y label is population. I'm adding a title to the graph, bubble chart with GDP mapped to color and size. Next, I'm rotating the x-axis labels for visualization. I'll show you what that means once we show the plot. And finally, we show the plot. The X label is at an angle at 45 because I've changed as X6 rotation to 45. And the darkest color implies more GDP. Qatar has more GDP. The lightest color has less GDP. The same could be seen here. The GDP is 1304475 for the first country, Qatar, and it is less for all other countries. That's why the darkest color is more GDP. Now also the size of the bubble is mapped to GDP. That's why the bigger size bubble means high GDP. You could also map the size to population. If you map it to population, let's see how it changes. So we could see the highest population has more size. This is population, and lowest population has less size. The different ways we could use Python and Matplotlib library to display, visualize the data. That's all for this video. Thank you for watching.